Okay, this time I will discuss about another subtopics under communication system, which is the electromagnetic spectrum and bandwidth. All right, as you maybe still remember in our previous discussion regarding the introduction to a communication system, one of the elements, the basic elements of a communication system is the channel or the medium. All right, all the electrical and electronic signals radiates into the free space as electromagnetic wave. Okay, so electromagnetic waves is basically signals that oscillate, that is the amplitude vary at specific rate sinusoidally. What means by this, if you have let's say we capture this using oscilloscope, you see something oscillates between up and down and in the form of a sinusoid wave. All right, and the frequency is measured in cycle per second or in hertz, right? So the electromagnetic wave covers a broad range of frequencies, and the range that covers the whole frequencies, which is the lowest into the highest frequency, is called the electromagnetic spectrum. Okay. All right, as you can see here, this chart shows the range or the electromagnetic spectrum in terms of the frequency. Okay, these are the frequency range down here, lower to the higher frequency, and then to the left side is the wavelength. Okay, all of the frequency range takes its own bandwidth here. For example, from 30 Hz to 300 Hz is defined as a extremely low frequency. And then VF 300 Hz to 3 kilohertz is basically our voice frequency. Okay, so our voice, every time we speak or we talk to others, whether face to face or over the phone, is actually taking this range from 300 Hz to 3 kilohertz. And then move on, we have very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and then extremely high frequency. And then we move into the optical spectrum and visible lights and ultraviolet range. Okay, as you can see here, the lower the frequency, the higher the wavelengths. Okay. For example, the frequency of extremely low frequency of 30 Hz will have a wavelength of 10 to the 7 meter. So please remember about this, because we'll see the significance of wavelengths with regard to the frequency when we learn about the modulation techniques later on. Okay, so our communication channel, which is our phones, telephones, television, radio, and so on, basically take this middle range of called as a radio wave. Okay, so this is the electromagnetic spectrum. And then another term that I would like you to know, it's very important in this lesson, is in terms of the frequency and wavelengths. Okay, So the frequency is the number of cycles of a repetitive wave that occurs in a given period of time. So how many times a cycle happen in a certain period of time is defined as frequency, and the wavelength is the distance occupied by one cycle of a wave, and it is usually expressed in meters, the units. Okay, let's see what means by frequency and wavelength, if you can draw it. Okay, so so this is the x, the y-axis is the amplitude. Okay, so if it is electronics or electrical signal, it could be in millivolts units or ampere, or it can be in voltage. Okay, and then on the x-axis, so we have the time measured in second or millisecond. All right, so a complete cycle of wave, all right, is called a one cycle. All right, so and shows as t in second. Okay, so next, so this is in terms of frequency. Frequency can be calculated by the f over 1 t. So let's say if the cycle is 0.1 second, then f is equal 1 over 0.1, which is 10 hertz. Okay, and if you have a higher frequency, the waveform will look something like this, which is in one period of time it has more cycles compared to the lower frequency. Okay, so the higher the frequency, the more cycles you will see in terms of the same period of time. Okay, and the calculation is still the same. All right, so in this case, let's say the one cycle is here, from here to this one is considered as one cycle. Maybe let's say, just for example purpose, we say this is a 0.0005. so this time the frequency for this waveform is 1 over 0.0005. so what is going to be 1 2 3 4. Okay, so it's gonna be a 5, if I'm not mistaken, please correct me, 5,000 hertz equal to 5 kilohertz. Okay, because it has a higher frequency. All right, next is the wavelengths. Okay, the wavelength is the distance traveled from one cycle of wave in measured in meters. So in this case, we are measuring the wavelengths in a free space, so we are using parameters, which is the speed of light, which is c. Speed of light is 3 to the times by 10 to the power of 8. So the formula for wavelengths, so normally usually expressed as lambda equal to c over frequency. And then let's say we have something like this. The frequency is let's say 100 hertz. Okay, so in this case lambda equal to 3 to the power of 8 divided by 100. Okay, then you have a wavelength in meters. All right, so let's see a few examples. What is the wavelengths? What is let's see some example. What is the wavelengths, which is lambda, for 150 megahertz frequency? Okay, so the wavelengths, if you use the formula just now, wavelength equal to C over F equal to 3 to the power 10 power of 8 divided by 150, which is power of 6 megahertz. If you take this one, actually 300 times power of 6 and then divide by 150 times to the power of 6, so we can cancel out this one, and then we have 300 divided by 150, and then we have actually the wavelength is 2 meters. So for 150 megahertz frequency, the wavelength is 2 meters. Say let's say another example. This time let's use the frequency is equal to what about 8 megahertz. Okay, so wavelength is 300 times this one divided by 8 megahertz equal to 300 divided by 8, so you have 37.5 meters. So you see, as you can see here, okay, the higher the frequency, the shorter the wavelengths. Okay, so this one 150 is higher than 8, so the wavelength for 8 megahertz frequency is higher than wavelength of 150 megahertz. Okay, so apart from calculating the wavelength distance, sometimes let's say we are given we have a frequency of wavelengths 1.5 meter, so we want to know what is the frequency for this wavelength. So we can use the same formula. So the frequency is equal to C over the wavelength, which is 300 times the power of megahertz, okay, divided by 1.5 meter. So we have 300 divided 1.5 times this one. So what we have here is actually we have a frequency of 200 megahertz, which occupy the wavelengths of 1.5 meter. Okay. All right, another example. This time, let's say instead of using meter, we want using the feet. All right. So let's say we have a lambda of 75 feet. Okay. So first, we have to convert this into meters, which is 1 meter equal to 3.28 feet. So 75 feet, okay, is equal to 75 divided by 3.28, so we have 22.86 meters. Okay, so then we can calculate the frequency equal to 300 divided by 22.86 times the 10 to the power of 6, so we have 13.12 megahertz. Okay, so now you know how to calculate what is the frequency, what is the wavelength if you're given certain parameters. Okay, the next term that I would like to explain is the bandwidth. Okay, so the bandwidth is the frequency range over which equipment operates. So each equipment, even our telephone, our smartphone, okay, operate in certain bandwidth. Okay, we can only occupy certain bandwidth. Or another meanings of bandwidth is actually the between the upper and the lower frequency limits of the signal or the equipment operation range. So what means by this, let's say if you look at the electromagnetic spectrum I showed in the early of this lecture, okay, you can see that our voice frequency is range between 300 Hertz to 3 kilohertz. Okay, so the bandwidth for this voice frequency is we can know this is a lower frequency, name it as upper frequency, is a frequency of upper minus frequency of lower, which is 3 kilohertz minus 300 hertz. So you will have 2700 hertz of bandwidth equal to 2.7 kilohertz. So this is the bandwidth. Okay, so if you have we have a frequency here. This is amplitude of a signal. Let's say the signal occupy the frequency like this. Okay, right, so the bandwidth is basically the upper frequency, and it is frequency of lower. So the bandwidth of this signal is f upper minus f lower. Okay, so then now you understand what it means by the bandwidth. Okay, all right. I think that's it for this explanation. So before we end, I just want you to know that frequency spectrum or electromagnetic spectrum is actually equal to, these days maybe you don't know about this, is equal to money. It's actually natural resources, because if you want to use any spectrum or any bandwidth for your communication channels, or you want to build your own communication company later on, so each of these bandwidths is controlled by regulatory body. Okay, so in our company, our country is controlled by SKMM or MCMC. Okay, so anyone who would like to use any bandwidth for their company, for example, instead of a Celcom, we want to create another telco company, so we have to apply and get the license from this regulatory body for us to be able to use. So which means every time a new company or any new devices want to use any spaces between any bandwidth, so they have to pay. Okay, so that's why you cannot simply hack or use any bandwidth without the acknowledgement or license from this regulatory body. So the function of this regulatory body is to monitor the usage of the frequency spectrum or EM spectrum, to allocate the bandwidth to companies, organization, or anyone who like to use it, and to license, to approve the license, and then also they are the ones that look into the law and acts regarding this frequency spectrum usage. All right, so that's all for today. I hope you understand about our lecture today, which is regarding the electromagnetic spectrum and also the bandwidth. So I'll see you in the next lecture. Thank you very much.